Hi everyone, and welcome to the Allplane Podcast, where we talk with the movers and shakers that are redefining the future of commercial aviation. As usual, before we start, let me remind you once more that all previous episodes of this podcast, as well as many other aviation stories, are available on the Allplane website. That's Allplane.tv, Allplane.tv. So now let's go to today's episode, because we combine two of my favorite topics, seaplanes and electric aircraft, because our guest is none other than George Alafinov, founder of Jekta, a startup based in Switzerland that is developing an all-electric battery-powered seaplane for regional air transport. The Jekta seaplane is still a few years from being operational, but it has already started to get the attention of some operators. For example, Jekta recently got a pre-order for 50 aircraft from India, a country that is likely to see its regional air transport market develop significantly over the coming years. With George, we talk about the pros and cons of seaplane operations, about his previous experience as a seaplane designer, and also why this type of aircraft fell out of fashion with the advent of the jet era, and why now it's time for a comeback, but with new clean technologies that bring also reduction of operational costs. Last but not least, we also talk about Jekta's Swiss home and how this country in the middle of Europe is becoming a magnet for clean aviation innovators. So tune in for our far-ranging conversation with George Alafinov, founder of Jekta. Hi George, how are you?
Hi Mikel, it's a pleasure to be here. Thank you very much for inviting me.
Well, thanks so much for accepting to be here on the podcast talking about your very interesting project, an all-electric seaplane. I don't know if I should call it a seaplane or an amphibious plane. I'm not too familiar with the nuances between the two terms.
Yes, I think this particular aircraft, it's correct to call an amphibious aircraft. Very simple. A seaplane is only intended to be used underwater and water-to-water operations. And amphibious aircraft is designed to be operated at different possibilities, whether it's water-to-water, land-to-water, or land-to-land.
Mm-hmm. Very interesting. Basically, first of all, I would like to ask you to introduce yourself. We're going to then talk about your project, Jekta. As I mentioned, it's an all-electric amphibious aircraft for 19 passengers. You are developing this in Switzerland at the moment, but with global ambitions, because the market for this type of planes is global. And actually, I think you recently got your first order or pre-order, I don't know how to call it, but from India.
Yes, thank you very much. I'd like to start with correcting. The first customer for our aircraft is actually a company that is a Swedish Dubai company. But you are correct in assessing that they are planning to use this aircraft in India. So my name is George Alafinov, or George Alafinov. I'm the Chief Executive Officer and co-founder of Jekta Switzerland. Our team, driven by my father and our chief designer, has been building amphibious aircraft for the last 20 years. And besides many other experimental aircraft, we have successfully designed, certified, and manufactured two amphibious airplanes. A two-seater ultralight amphibious aircraft and a 8-seater twin-engine amphibious aircraft, both of the flying boat design.
Interesting.
And it was it was during a sales pitch in India I think it was 2017 or 2018 for the 8-seater aircraft. We came to a realization that a bigger aircraft is required to serve the needs of both the existing and the emerging markets. And one of such markets is of course, India. So we went to the drawing board and started outlining the future 19-seat amphibian aircraft. Of course, at the time, the intention was to design an aircraft using conventional powertrain, a turboprop engine. The best possible engine out there was the famous Pratt & Whitney 56, a very good legacy engine. However, albeit many modernizations over the last 60 years, this engine is still thirsty, loud, expensive, and in some ways simply outdated, even though it's probably the best conventional engine out there. Therefore, and simply for research purposes, we have started to look into the possibility of electrifying the 19-seat aircraft. And to our surprise, we have come to several conclusions.
Which ones?
Well, that given the characteristics of the regional travel, i.e. the regional mobility, be it to land, water-to-land, or water-to-water, with the present-day technology, it's already possible to design a fully electric regional amphibious aircraft with multiple operational parameters that can serve the majority of regional land and water routes. And B, that electrification provides a direct economic benefit to our customers, the regional operators, by reducing the operating and maintenance costs. And last but not least, through flying boat design and the use of modern composite materials, we're able to provide an aircraft that can be or effectively used on both land and water without need for any additional parts or additional maintenance. And that's how the Phase 100 project was born.
Mm-hmm. I've got a few questions here, having reached this point. Some of them are about the actual seaplane or amphibious aspect of the project, and some others are about the electric side of things. So let's start by the amphibious part. Seaplanes or amphibious planes were very, very popular in the early years of aviation up until the Second World War. They were even like the mainstream way for people to travel in many parts of the world. But then they fell out of fashion. And since then, they kind of remain sort of a very, very small niche. I mean, there are few operators out there, but not so many aircraft. What is changing now that you think it's going to make it a much more attractive proposition for operators out there? And the second question connected to that is on the, let's say, the electric technology. One of the main issues is range. So what is the range of your aircraft, and how you plan to solve this with the energy density of the batteries? We have seen a few announcements lately about more performing batteries and all that, but it seems to be a big hurdle at the moment for entrepreneurs that are trying to electrify aviation.
Well, you're very correct in terms of history of seaplanes. Seaplanes have been around since the early 20th century. They were very popular at the time, particularly in the first few decades, because they were able to access remote areas and provide transportation to locations that were not easily accessible by land. But more importantly, because the developed world, and we were talking about Europe and the United States of America, had at that time yet a lack of airports and airport infrastructure. So there you had international hubs, but you didn't have all those small airports that my colleague from aviation mentioned at your podcast about, I think, 3,000 or 2,300 something airports, regional airports in the United States of America. However, as technology improved and airports became more widespread, seaplanes lost popularity due to the fact that they always required a lot of maintenance. They were made all of metal, and water do not coincide very well. They also, land-based aircraft have additional payload because they don't have the reinforced hull. Therefore, the manufacturers were able to provide more payload for those operators. And with the spread of the infrastructure in North America and in Europe, the operators started looking into carrying passengers from airport to airports, and therefore they started building more airports in the vicinity of the city. And not all the cities are based on the water, whether it's river or lake. And this was one of the initial reasons why the seaplane started to decline. Another one was the fact that after the World War II, and as you know, the biggest seaplane, if I'm correct, was the Spruce Goose, 1944, by Howard Hughes.
Yeah, it was the largest, I think. I'm not sure about the dates. I think it even stretched a bit
45
after the war, yeah, but around the second half of the 40s, yes.
Something like second half of the 40s. And then in the 50s, we came into the age of the jet engine, and the passengers start looking into flying further, flying faster, and flying at higher altitudes. And with the modernization, of course, of a car industry and the ability to drive cars at the faster speeds to certain locations, the need for seaplanes that are operating short routes have started to decline further because it became a little bit less fashionable, and people started looking more into the jet era. And then since then, over the last 60 years, 70 years, we had this huge boom in jet travel. So now we're able to fly from London to Australia or to Argentina using jet engines. However, with the new increased interest in regional and urban mobility, us and a lot of other manufacturers started looking into what the possibilities for water operations can provide for the regional mobility. And therefore, in recent years, there has been a renewed interest in seaplanes, exactly for the particular for the ability to access remote or island locations or difficult or impossible to reach destinations. And with advances in technology, we see seaplanes that can become more efficient, reliable, and safe, and can be used for a wider range of applications. And to answer your second part of the question about the battery density and range, we have a list of all operators around the world. There's about 350 companies, where they're ranging between Trans-Maldivian Airlines that has about 60 aircraft to many operators that have one aircraft.
Sorry, it's 350 operators of seaplanes, of amphibious aircraft
Seaplanes
in the
yes,
world.
Yes. This is based on the list that we have.
Okay.
The average distance traveled for that operator is 84 kilometers.
Okay.
So we're talking about really short range regional routes. And therefore, when we're talking about the present possibility for battery density, and I think we're already at 250 watts an hour, there is expectation at 300 watts an hour at the end of this year. And as you know, there was the biggest battery manufacturer in the world. Has
Chinese
just presented, I think, last week. Yes.
Yeah, 400.
They have presented closer to 500.
Yeah.
Probably less than that, but that means that there's an intention, there's a possibility for growth. Now we're looking into the future, and we are looking at the presentation of the aircraft in 2029. So we have quite a few years to go to see how this technology develops, and we're absolutely confident that the technology in the battery density will be there in order to fulfill those particular characteristics of operators in our market.
I have one question about the batteries. It's about how batteries respond to the sort of salty environment that these aircraft operate in. I don't know if the sea salt can be an issue in terms of corrosion when it comes to the batteries, the same way that you mentioned the issues with maintenance for metal parts in a maritime environment when these aircraft operate in seawater. And I think that's actually one of the main issues as well that operators face, is the maintenance cost when they operate in seawater. We had quite a long time ago here a seaplane entrepreneur in Florida that gave us some numbers. I don't remember them exactly, but every time the plane touches the seawater, it requires a huge amount of maintenance just for the very fact that being few minutes in the water. How does it apply to batteries? And you mentioned, I think, you are working with materials that kind of overcome this issue. What else can you tell us about how you plan to solve this?
Well, first of all, of course, a direct contact of the battery with sealed water will be catastrophic. And that is why you engulf the battery in a special closed compartments and make sure there is no water getting inside. Of course, it will be catastrophic in a way that there will be some degradation, and battery will need to be changed. But again, this is very easily overcome during the design stage, where you place your batteries in the specific compartments that do not allow for the water to be penetrated and touch the batteries. You're absolutely right that all modern seaplanes that are out there are made of metal, and it requires an average between 4 to 6 hours a day to clean those from the salt water because of the possibility of rust and degradation of that metal part. Well, here the solution is very simple. Don't use the metal. So that's why we're designing the aircraft fully out of the composite materials, which are not afraid of salt water or seawater. Additional element to this is that all the modern or current aircraft seaplanes are using conventional engines with open engines, and there's a chance of the salt water, seawater getting inside those engines, so those engines also require additional cleaning. But once we're moving to the electric motors, and therefore everything you have outside is a propeller made of either composite or wood, and a governor, and the rest is encompassed in a box in the controller box and behind the carpets and behind the fuselage, you have no chance to receive any seawater on those parts, and therefore there is no risk of any degradation and doesn't require any additional maintenance.
And where are you now with this design process? Where is the project at the moment in terms of development? Have you already started work on a prototype? What's the time frame that you have in mind for certification and then entry into service?
Well, it's a bit too early to talk about the prototype. We're about 6 years away from the first delivery as per plan. We're about 4 years away from starting presenting prototyping for the certification processes. Of course, certification is not only the work on the prototype by the EASA regulator or FAA regulator, but it's also a lot of documentary work. We are now we've just completed the conceptualization stage. What is the conceptualization stage? Is where we know what we're building, we know what parameters we're looking for, we know what are the markets that we're looking at. Therefore, what are the specific tasks that this aircraft should perform? We're looking who we're going to work with in terms of supplying, because half of the manufacturing is working with a supplier. As an aircraft OEM, we're not willing to reinvent the wheel or start building our own engines or propellers. No, our job is to design the best aircraft possible and work with leading world suppliers for these respective parts in order to assemble the best aircraft we can. That's why we have teamed up with Honeywell to design and to use their control systems and their avionics in our aircraft, and to work together on the capability of this aircraft for automatic takeoff, landing on water, which nobody's ever done before. And I think together with Honeywell, we're able to achieve it. And another thing is to create HMI system for the water taxi.
What is that?
It's a human machine interface.
Okay.
So it's how do you work as a pilot? How do you work with the avionics in front of you, and how the machine itself, through automatic navigation on the water, can help you as a pilot, whether it's to dock the aircraft or to get out of the dock in the aircraft, or in certain geographical areas, whether it's a bay or river, providing the best possible information to the pilot to make the best decision during the taxi on the water.
Mm-hmm. Because one aspect I've seen of the renderings you have on your website is that the Jekta aircraft is going to be resting on the water, so the hull is directly in contact with the water, instead of resting on some floats or some other system. What is the advantage of this type of approach? In the 1930s, like I think the Pan Am Clippers and these very large seaplanes, they were also resting completely on the water.
Well, absolutely. Well, when we're talking about the seaplanes, we need to divide seaplanes in two different categories. First is the land-based aircraft that is adapted to be operated on water by installation of the floaters. By doing so, the aircraft obviously gains additional weight, therefore reducing the payload, versus the land version of the same aircraft. It also decreases the aerodynamics of the aircraft, resulting in slower speed and increased fuel consumption. And actually, all current sea operators around the world are using land-based converted aircraft with floaters, be it twin otters or Caravan or others, simply due to the lack of current alternatives. Now, these aircraft are not designed to be used in water; they're simply adapted to it. Therefore, they're initially made out of metal. They're initially made of certain aircraft design solutions that are simply not the best if you use it on the water. Now, the other seaplanes, as you correctly mentioned, is the flying boat design, meaning that the bottom part of the hull is reinforced, as this is the surface of contact with the water. And such design provides for much wider operational parameters, as it is able to cut a larger wave and therefore can be operated in rough conditions and bad weather. In our case,
sorry, how rough? Because I know the traditional, like these amphibious aircraft you mentioned, they're pretty limited in what they can do when there's just a little bit of crispy water, just a bit of wind, a bit of wave, not too high. It's already a no for those aircraft. So
absolutely.
What's the difference
You're
in your
absolutely right.
case?
Well, in our case, we're planning to build an aircraft that will allow for operations up with a wave height up to 1.2 meters, which providing for the possibility to use it in open ocean.
Yeah, it's pretty big, 1.2 meters. So.
Of course, the downside of that the reinforcement of the hull means additional weight of the aircraft.
Mm-hmm.
On the positive side, the additional reinforcement of the hull provides for additional safety, as in case of emergency, you can either look for a body of water to land, but more you can try to land on the hull itself.
Mm-hmm.
And as a reinforced hull, it provides for that possibility. And these are two very strict differentiations between the land-based aircraft that is adapted to water and a seaplane of a flying boat design. Now, I'd like to say that flying boat design is a truly amphibious aircraft, because most of the land-based aircraft with floaters, not all, but most of it, cannot be used on land unless you take off those floaters. So once you convert it, first of all, those floaters are additional cost. They are from third-party manufacturers. They're quite expensive. The usual permission of the wave height, if you ever see a floater aircraft, is you take the height of the floater and half of it is the usual permitted wave height with a very experienced pilot. Because as you understand, once the wave gets up and down, your aircraft, which is sitting above the floaters, starts to move in this lateral kind of movement, and there's a possibility of getting a nosedive into the water, which is of course dangerous.
Yeah. Mm-hmm.
Now, those floaters, once you install them on this land-based aircraft, has to be taken off if you want to fly land to land. Not all of them, but most of them. And this provides for additional costs, for additional time lost, and will not actually create a truly amphibious aircraft. Now, the Phase 100 is an aircraft that is designed to penetrate and expand the regional air mobility market, talking about the niche itself. And being a truly amphibious aircraft, it allows for our customers to operate the aircraft both on land or water, or combination of both of the two, without any additional investment or any additional work. It also provides for possibility to homogenize the fleet of the operator that is willing to have both land and water operations. So one aircraft can fly to the water base and another aircraft can fly to a different airport. And then if one of them is AOG, you simply take the other one and he performs the same routes. Today, the water operations are mostly in the so-called developed countries, Canada, some parts of North America and Caribbean, Europe, and several island chains such as the Maldives and the Seychelles. And this we consider as an existing markets. But we want to look beyond that. The regional air mobility will expand to the developing countries, and new markets are already emerging today, expanding the regional travel. And these include India, Malaysia, Indonesia, Philippines, Africa, and South America. A lot of these emerging markets are either unwilling to invest in regional airport infrastructure, such as India, due to high financial costs and irreversible ecological impact, while others, like Indonesia, are unable to do so due to the scarcity of the landmass. So we'll also see new water bases emerging in Europe, for example, due to extreme high cost of land. And all of this pushes local governments to look into alternatives for the regional transport of goods and passengers using water. And a good example of this is a SWAN program in Italy. And I don't know if you heard about it. So SWAN 1 was just recently completed. Its aim was to harmonize the regulations of several countries on the Adriatic Sea. And now comes the SWAN 2 program, which is to build 15 water bases connecting Italy, Croatia, Albania, and Montenegro, with the first water base being in Gallipoli, in process of being built right now. And the SWAN stands for Sustainable Water Air Network. So it's really using the water and connecting all those countries and creating a regional mobility for the passengers and the goods to travel around the Adriatic Sea. But again, our aircraft or any amphibious flying boat design aircraft are not focused only on water operations. It doesn't require anything additional to be flown on land routes and can be perfectly operated from airport to airport. And certainly that also provides for possibility to bring passengers from and to international airports from water, be it in Dubai or in Jakarta. And that makes Phase 100 an aircraft with what we call a multiple operational possibilities. With one aircraft, you can do all three: land to land, water to water, land to water, whatever is required at that time or at that geographical area where you operate.
And how does it compare in terms of operational cost to the existing alternatives?
Well, that's a good question. That is exactly our aim, because as you very well know, and as a lot of guests on this show before me mentioned, the electrification of aviation is specifically targeting the reducement of the costs, running costs, and the maintenance costs. And this is the goal here. And this is why the regional aviation was unable to expand into the developing countries, because the local population is unable to purchase flight tickets at $300, $400 a seat. But once you reduce those operational maintenance costs, whether it's through the design, using new materials, using electric engines, using the batteries, suddenly the operator is able to reduce those tickets prices and offer for the passengers or the cargo companies completely other possibilities in terms of pricing. And now suddenly we arrived at a situation where hundreds of millions of people in India and tens of millions of people in Southeast Asia and South America are able to purchase those tickets and able to use the services of regional air mobility because of those particular costs on prices. The operational costs through electrification and through using modern composite materials and therefore decreasing the running cost, the operational costs, and the maintenance cost is the main target here. Because by decreasing those costs, we have the possibility to expand the regional air mobility in the developing markets where the population is unable to pay the tickets using the current possibility for the seaplane markets, for the seaplane operators, for the seaplane aircraft. But once we decrease those costs, suddenly we have hundreds of millions of people around the world that are able to purchase the tickets and to fly, whether it's 40 minutes or 50 minutes or 1 hour for another state or another city, or visit their relatives in another island, for example.
Have you quantified?
And that is only
Have you quantified how many aircraft are we talking about potentially?
Yes, we are talking about the current need of 2023 of about 400 aircraft for the seaplane operations only around the world.
That would be to replace based on the existing aircraft, or also taking into account this potential new induced demand from a lower cost?
No. This is only what is required today is an additional aircraft to the existing ones. Okay. Now there's about 1,000 seaplanes around the world of different kinds in commercial operations. And I like to mention Trans-Maldivian aircraft, that's 60 twin otters, only one operator. So those we do not take in consideration. We're talking about there's a need for about 400 more, and this will only grow as the Southeast Asia wealth increases. They simply don't have any possibility other than use seaplanes to fly around regionally. But I don't like focusing only on the water operations. I believe that this aircraft is able to compete with other players in regional mobility, the likes of aviations or Viridian or others in operating land-to-land routes as well. Okay. Being a 19-seat aircraft also has advantages for the operator, because every operator wants to have as many passengers as possible in order to maximize their profits.
Cargo as well?
Our cargo as well. And we learned it the hard way, manufacturing an 8-seater, so 6 passengers. And a lot of operators just came and said, well, this is too small. The economics are more difficult. So it's actually the bigger you go, the better economics are there for the operator, considering the high costs, especially high entry costs. And this really is a changer for the operator. But as we want to stay in part 23, and we don't want to go too big by eliminating the possibility of using this aircraft in tight areas, such as the Amazon River or bays, we want to limit ourselves to 19 passengers. Another thing that we should speak about is the difference between the urban air mobility and the regional air mobility. And regional air mobility will be much bigger. I had the pleasure to be at the presentation of Daryl Swanson of the EA Maven at the Revolution Aero just 2 weeks ago. And there's some absolutely striking numbers about the possibilities in regional air mobility versus the urban air mobility. So when we talk about urban air mobility, we're talking about eVTOLs and variations of eVTOLs. And I guess that's including helicopters. The possibility of regional air mobility through the electrification and through the decrease of those prices is suddenly allowing for not only competition with other operators, but actually competition with other means of transport, such as train and such as the car itself. Now, with the increased taxation on cars, with a lack of infrastructure, train infrastructure in some countries, regional air mobility is going to grow exponentially. And we're talking about, I think, about 250 million travelers annually on the regional air mobility. And that is a huge, huge number. And this is why we're building this aircraft to encompass all kinds of market. And this is why we focus on building water and land aircraft, so it can apply and be applicable in different countries and different markets, whether you're going, as I mentioned, in the Philippines from island to island, or you simply fly from Inverness to Aberdeen, or from London to Cardiff, or from Miami to Fort Lauderdale.
And that would be the same version, exactly the same aircraft.
Exactly the same version with no changes at all. And we believe this is a big advantage because it allows us as a manufacturer to expand our possibility of the market. But as any operator looking that there's 500 or 1,000 of this aircraft around the world, that means at the end that there's a decrease in pricing for parts. There's an increase in technicians, in service bases around the world, pilots, etc., etc., etc. So while expanding and homogenizing this particular regional air mobility market with one aircraft, we're actually giving a direct benefit to the operator.
Understood. There's another thing I wanted to comment on. Developing an aircraft from scratch, getting it certified and getting it to the market costs a lot of money. You're a startup. Have you received VC capital, venture funds? You have private investors. What's the actual, let's say, financial setup of your project?
Well, luckily, we, as I mentioned at the beginning of our conversation, we've been developing amphibian aircraft flying boats for 20 years. We have our own financial capabilities. We already have the team that has been working on a lot of flying boat designs, and we're using the same key people. So up to now, we have been, the founders have been financing this project ourselves, using, again, the same team that's been working with us for many, many, many years. And simply from this month on, we are opening our series of funding, which I believe it's called the Series A right now. And we start the process of looking for the investors and for financial companies, whether it's VCs or private equity or any other interested parties that are interested in investing in Jekta.
So if there are any investors listening, there you go. You have here an interesting project to invest in. What's next? You currently are based in Switzerland in something called the Swiss Aeropole, which is a sort of hub for different Swiss startups. Actually, we had some previously here on this podcast, some interesting startups from Switzerland, like H55, which is a company also active in the field of electric aviation. What are the perspectives in terms of let's say the physical part of the venture, building stuff, making stuff. I mean, you mentioned you already designing aircraft, so I guess you already have some sort of facility where you are basically working on this from a, let's say, from a manufacturing point of view.
You're absolutely right in the fact that I think you had two guests from Switzerland before. One is the H55. We know them very well. They're developing and they've already certified, very a battery for aircraft,
Yeah,
for electric aircraft.
And led by a very, let's say, iconic aviator, which is André Borschberg, which was with André Picard in that famous tour around the world in a solar aircraft a few years ago. So, yeah.
Well, I had the privilege to know both of them, and I have a privilege to know very well André and his partners in H55, and we in continuous conversation and the possibility of using their technology. This is one of the advantages being in Switzerland. Another one is a good neighbor of us, Mikhail from Destinus.
True,
He's
yes.
in the same Technopark. We are, Jekta is a Swiss OEM. We were registered in 2021 with the aim of designing and manufacturing aircraft, and the first project being the Phase 100 amphibious aircraft. We're situated in Swiss Aeropol Aerospace Cluster, which is an airport of Payerne in Canton Vaud in Switzerland. It's actually one of the fastest growing technoparks in the country, in one of the most dynamic and innovative parts of Switzerland. And besides having access to one of the longest runways of 2.8 kilometers, we're also able to cooperate with various companies in the cluster, whether it be legal or certification or other purposes. Also, Solar Stratos is there with us. So we have a lot of, and as I mentioned, Mikhail with their hypersonic program. So we have a lot of very interesting and very innovative companies around us with whom we're able to share ideas and share this fantastic technopark with really fantastic possibilities and fantastic benefits for all the companies. And this is one of the advantages being in Switzerland. As you might know, the first electric aircraft was flown in Switzerland.
Okay, didn't know that.
The Pipistrel.
Yeah, true. Yes, actually, we had also now that you mentioned recently in the podcast, he's been twice on the podcast actually. Morel Westermann, who is based in Switzerland as well, and he is a pioneer of electric aviation as well in flying aircraft. In his case, he's been one of the, I think, very early pilots of the Pipistrel Velis Electro, and he's been setting up some records, distance records with this aircraft in the recent past as well.
Well, the reason for that is that the local regulator, the FOCA in Bern, are very acceptable to electrification of aviation. They're working in dialogue with a lot of manufacturers on the promotion of electric aviation. In fact, here in Switzerland, we have a lot of those electric Pipistrels in flight clubs and academies for PPL licenses. So if you ever want to fly that Pipistrel, you can always find it in Switzerland. And this is one of the advantages to be here, is that we can have a direct dialogue with FOCA. They're the edge of the innovation in terms of regulations and in terms of electrification of aviation. And of course, FOCA is the part of EASA. So at one hand, you have all the advantages and little disadvantages being here in Switzerland. And of course, additionally, we're able to cooperate with a lot of very famous technological universities with a lot of brilliant ideas, brilliant teachers and students, and brilliant laboratories. So if there's anything that comes up and we don't know the answer to, we can always go to this universities such as the Lausanne Polytechnical School, Zurich Polytechnical School, Neuchâtel and the others, and have direct access to the brightest and youngest minds in engineering. This is another advantage that we have. Of course, being in Switzerland, we have the possibility to build a product that is made in Switzerland, which always, first of all, sets a very high bar for us, of that it has to be the product of the utmost quality. And this is our full intention to do. But of course, it provides additional benefit for our shareholders at the end of the day. So being in Switzerland also is a big advantage because we're, as a neutral country, we're able to work with Japanese, with American, with all different countries. And this is also very advantageous for us. And we believe this is the best solution, is to make a final assembly of the aircraft here. But as I mentioned in the beginning, it's very important to have a very robust and a very extensive network of suppliers of utmost quality from the biggest brands and the most renowned suppliers in the world, that therefore we can assure the quality of the parts and the components that are coming into Switzerland. And this is actually the half of the job of any manufacturer, is the quality control and work with your suppliers.
Mm-hmm.
And we're able to do that.
And for people that wish to learn more, to follow this project as it evolves over time, which resources would you suggest? Could you please remind us now of your website or any other social channels you might have out there for people to check more information about the Jekta amphibious electric airplane?
Well, of course, everybody can visit us at the website www.jekta, that's Juliet Echo Kilo Tango Alpha .swiss, and follow us on LinkedIn as Jekta Aircraft, and look out for our press releases in all the mainstream airplane and aircraft publications.
Excellent.
And of course, those, sorry to interrupt, of course, those that are visiting eBay in our home country of Switzerland are always open to seek me out and talk to me directly.
I'm going to be one of those people visiting eBay's. So hope to see you soon in person and be able to continue this conversation there. Well, in the meantime, thank you so much and all the best with the project. Before you go, and if you like this podcast, a quick reminder that it would be absolutely great if you could please give it a rating on Apple, Spotify, or whichever platform you're using, or recommend it to a friend or whomever might be interested. Thank you very much and see you soon.